This video is the final video in our graph by transformation sequence. We're going to be graphing the equation y equals the absolute value of negative x plus 3 minus 4 by transformation. We will state the domain and range and interval notation of our final graph. The first thing you want to do is establish your plan. And the first part of the plan is identifying what the parent function is. We know it's going to involve x, and then whatever operation is happening on x other than add, subtract, multiply, divide. Notice that there are absolute value bars to this equation here. That tells us that our parent function is going to be y equals the absolute value of x. Now we start looking for transformations in order. The first transformation we're looking to see if it exists is a horizontal shift. We recognize a horizontal shift when we have plus or minus a number inside the function. Do we have that? Sure we do. Plus 3 on the inside. So I'm going to add that to my black equation. Y equals the absolute value of x plus 3. That's going to give us our green equation, the result of the first transformation. I'm also going to note to myself that that plus 3 on the inside tells me that I need to shift to the left 3. The next transformation that we are looking for is a reflection about the y-axis. We recognize that there is a reflection about the y-axis when we have multiplication by a negative inside the function. Do we have that? Sure do. There's a negative right there inside our absolute value bars. So now I'm building off the green equation and adding that negative inside to the green equation. We get y equals the absolute value of negative x plus 3. And I'm going to note to myself that this is a horizontal reflection, or maybe you say reflect about the y-axis. And I'm going to further note to myself what I need to do to the points. I need to multiply all of the x values by negative 1. The more detail you can put in your plan, the easier it's going to be once you are creating all your sets of points and drawing in your graphs. The next transformation we're looking for is a horizontal expansion or contraction. We recognize that there's a horizontal expansion or contraction when we have multiplication by a number inside the function right in front of the x. It needs to be a number other than 1, and we're not talking about the negative because that's a reflection. So do we have multiplication by a number other than 1 inside the function? We do not. So this equation is not going to have a horizontal expansion or contraction. That takes care of the 3 transformations occurring inside the function, and now we're going to turn our attention outside the function. The next transformation we're looking for is a reflection about the x-axis. We identify that there is a reflection about the x-axis when you have multiplication by a negative outside of the function. Do we have that? We do not. So this equation does not have a reflection about the x-axis either. The next transformation we're looking for is a vertical expansion or contraction. We recognize that a vertical expansion or contraction occurs when we have multiplication by a number outside of the function. Do we have multiplication by a number outside of the function? No, we do not. Therefore, this graph is not going to have a vertical expansion or contraction either. The last transformation we're looking for is a vertical shift. We recognize that that's going to happen when you have addition or subtraction outside of the function. Do we have addition or subtraction outside of the function? Well, yes, we do. That -4 on the outside tells us that we need to shift this down 4. Writing my blue equation, I'm building off the red. Y equals the absolute value of negative x plus 3 minus 4. And I'm going to note that we're going to go down 4. I double check that my highlighting on my original equation. I make sure that everything's accounted for other than the x and the absolute value bars. It is. So I feel confident proceeding. Now we need to get some points so that we can graph our graphs. We'll start with the points for our parent function. The absolute value of x passes through the points -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And I'm going to go ahead and graph those points. Remember the basic shape for absolute value. It has a V shape. I always try to think about those things as I'm going from my equations, my points, to my graphs. It'll red flag me if I've made a mistake. We plot our 5 points, draw in the graph. It is the V shape that I am anticipating. Now we're ready to transform it. Our first transformation is that we need to shift it to the left 3 units. Think about which coordinate is going to change, the x or the y. The x, since we're going to the left, and are we going to add 3 or subtract 3? Since we're going to the left, smaller x's are to the left, we're going to be subtracting 3 from all of our x values. That gives us the points -5, 2, -4, 1, -3, 0, -4, 1. I'm sorry. -2, 1, and -1, 2. Again, you'll notice I'm color coordinating. Green equation, green points. Going to draw a green graph. And we move all of our points. Drawing in our graph, we see we've shifted our black graph to the left 3. We're ready for our next transformation. We need to take our green graph and reflect it about the y-axis. To get the correct points, we're going to take the x values of our green points and multiply those x values by -1. Gives us the points 5, 2, 4, 1, 3, 0, 2, 1, 1, 2. Plotting these new points. And then we draw in our graph. There in red, we have the graph of y equals the absolute value of -x plus 3. But that's not our final answer. One more transformation to go. We need to take this red graph and we need to shift it down 4 units. I need to think about how it's going to affect those red points. We're going down 4. Therefore, we need to subtract 4 from the y values of our red points. This gives us the points 5, -2, 4, -3, 3, -4, 2, -3, and 1, -2. Oftentimes on a quiz or an exam, I will ask you to state the points on your final graph, just so there's no ambiguity on what you're saying your answer is and what I'm seeing your answer to be. Plotting our points. We draw in our final graph, which is our answer. The black, green, and red graphs were just a means to get to the end, and the end is our blue graph. This is indeed our answer. We need to state the domain and range. When stating the domain and range, we are talking about the final answer. I will only refer to the blue graph when stating the domain and range. Our domain, since we have an arrow to the left and an arrow to the right with no breaks in the middle, is -infinity to +infinity. Our range, we have arrows pointing up but not down, so our range starts at a particular number. It's going to be at the bottom of our V shape, which is -4. And then the arrows pointing up tell us that we're going to +infinity. We have a domain of -infinity to +infinity and a range of -4 to infinity.